Hi everyone, welcome to On-Process Math. In this lecture, I'm going to talk about U-substitution with definite integrals. And I'm assuming that you're fairly familiar with U-substitution method. If you're not, I suggest you to watch my previous videos on U-substitution and U-substitution with linear functions. Let's get started with a simple example. So suppose we want to find this the definite integral of this function over the interval 0 and 1. I'm going to take u to be equal to 1 plus x squared, and notice that the derivative of 1 plus x squared is 2x, and I see the derivative as a factor here. So that means that this substitution, that's a good sign that this substitution is going to work. So the next step would be to compute du. Du is going to be derivative of 1 plus x squared, 2x multiplied by dx. I have taken u plus x squared to be u, so 1 plus x squared to the power of 3 will be replaced by u to the power of 3. And then 2x dx, using this formula here, will be replaced by du. Now the last step is to also update your lower and upper bound. These are the lower and upper bounds for x, not u. I need to compute the lower and upper bounds for u. And for that, you use this relationship between u and x. So the lower bound for x is 0. If you substitute x by 0 here, you will get u equals 1 plus 0 squared, which is 1. And that's how you get the lower bound for u. And you repeat the same process for the upper bound. The upper bound for x is 1. If I substitute x by 1 in this formula, I'm going to get u equals 1 plus 1, which is 2. And that's how I'm getting the upper bound. Now everything in this definite integral is in terms of u. I have du here. I have only a function of u, there are no x's, and the upper bound and the lower bound are also written in terms of the new variable u. Now we can go ahead and compute this definite integral. Integral of u cubed is u to the power 4 divided by 4. I'm using the power rule here. 3 plus 1 is 4, and I divide by the same number. And this needs to be evaluated between 1 and 2, between the endpoints of this interval. That means substitute u by 2, substitute u by 1, and subtract. If you substitute u by 2, you're going to get 2 to the 4 divided by 4. If you substitute u by 1, you will get 1 over 4. And you simplify that, and the final answer is 15 over 4. And notice that, unlike the U-substitution method for indefinite integrals, when you do substitution for definite integrals, you never substitute your x variable back. So you see, here I write everything in terms of u, and now this is the definite integral, so the result is going to be just a number. And I do the computations and find the final answer without bringing x back to the gain. So I never substitute x back. Let's look at the next example. So here we want to integrate the function sine x cosine squared x over the interval 0 and pi over 2. And notice that if you take u equals cosine x, then the derivative of cosine is minus sine. And I almost see that here. I don't see the minus sign, but I see the important part, sine x. And you know that when you're doing U-substitution, if you're thinking of some function being your substitution, you should see the derivative of that function up to a constant. So the minus sign is not going to cause too much trouble, but you want to see the main part of the derivative, which is sine. So if you see the derivative up to a constant, that's great, and your substitution is going to work. So I'm going to take u equals cosine. du is going to be the derivative of cosine, which is minus sine, multiplied by dx. And since I don't see the minus sign, I have just sine x dx I solve this for sine x dx. So sine x dx is going to be minus du. Now, I go back and try to write this definite integral, but everything has to be in terms of the new variable u. I've taken cosine to be u, so cosine squared will be replaced by u squared. Sine x dx, using this formula that we found here, is going to be replaced by minus du. Now, it's important to remember that we also need to update the lower and upper bound. This is the relationship between u and x. The lower bound for x is 0. If I substitute x by 0 in this formula, I'm going to get cosine of 0. So u will be cosine of 0. And that's the lower bound for u. And you repeat the same process for the upper bound. The upper bound for x is pi over 2, and this is the relationship between x and u. If you substitute x by pi over 2, you will get u equals cosine pi over 2. And that's the upper bound for u. Now, I have written everything in terms of the new variable u. I'm going to simplify this. So notice that cosine of pi over 2 is 0, so I'm going to replace that by 0. Cosine of 0 is 1. I'm replacing cosine of 0 by 1, and I put this minus sign outside of the integral. And notice that here the lower bound is larger than the upper bound. And generally, when you have definite integrals, the lower bound is smaller than the upper bound. And you can use this minus sign to switch the order. So I can write this integral as integral from 0 to 1, not from 1 to 0. So I can use this minus sign and change the order of lower and upper bound. Now this is a very simple integral. So what I'm using here is this property of definite integrals that you can, if you multiply a definite integral by a minus sign, you can change the order of lower and upper bound. Now this is a simple integral to evaluate. Integral of u squared is u to the power 2 plus 1, 3 divided by 3. And this needs to be evaluated between lower and upper bound. That means that substitute u by 1 and substitute u by 0 and subtract. And then the final answer is going to be 1 over 3. And again, notice that I'm not substituting the x variable back. So everything is written in terms of u here, and then you go ahead, you compute the definite integral, and you're done. Let's look at another example. So here we want to evaluate this definite integral x square root of x minus 1 from 1 to 2. The substitution that I'm going to make is u equals x minus 1 because I want to kind of get rid of this x minus 1 term under the square root. Then du is going to be the derivative of x minus 1, which is 1 multiplied by dx. So du will be dx. And I'm going to, from this equation, I'm going to solve for x. So x is u plus 1. And you'll see that we are going to need this in our computations. Now I have everything I need to try to write this in terms of the new variable u. So square root of x minus 1 will be replaced by square root of u. Dx is equal to du, so I replace that with du. And this x, I need to replace it in terms of u, so this x using this formula is going to be replaced by u plus 1. So now you see everything here is written in terms of the new variable u. But this is a definite interval. We need to update the lower and upper bound as well. So the lower bound for x is 1, and this is the relationship between u and x. If you substitute x by 1, you will get u equals 0. And the upper bound is 2. If in this formula you substitute x by 2, you will get u equals 2 minus 1, which is 1. And that's the upper bound for u. Now you're done. Basically, everything is written in terms of the new variable u, and we are going to evaluate this integral. And every time you have radicals in your expression and you want to do an integration, it's a good idea to write it as fractional power. So I'm going to write square root of u as u to the power 1/2. And then I will just multiply u to the power 1/2 by u plus 1. U to the power 1/2 multiplied by u is going to be u to the power 1 plus 1/2, which is u to the power 3/2. 1 plus 1/2 is 3/2, and that's how I'm getting this there. And u to the power 1/2 multiplied by 1 is u to the power 1/2. And now you just use the power rule to integrate these two functions. Integral of u to the power 3/2 is u to the power 3/2 plus 1, which is 5/2. So it's going to be u to the power 5/2 divided by 5/2. But instead of dividing by 5/2, you can just simply multiply it by 2/5. And similarly, for u to the power 1/2, the integral is going to be u to the power 1/2 plus 1, which is u to the power 3/2. 1/2 plus 1 is 3/2. So the antiderivative of this function is going to be u to the power 3/2, and you need to divide by 3/2 or simply multiply it by 2/3. And this is the antiderivative. It has to be evaluated between the lower and upper bound, between the lower and upper bound. That means that substitute u by 1, substitute u by 0, and subtract. If you substitute u by 1, you will get this. If you substitute u by 0, everything will be 0. And if you just simplify this, it's going to be 16/15. So this definite integral is 16 divided by 15. For additional practice, you can take a look at problems in section 6.1 of the Apex Calculus 2 textbook. And for any additional help, check out mathematicians.com.